All right, if you're not looking for Python for Evil, you're in the wrong room, and you want making music with Python, which is in room 2 or room A, depending on the numbering scheme. If you're here for Python for Evil, thank you for your attention, thank you for coming out, and thank you organizers for bringing me here from Austin, Texas. Yes, hook 'em horns. Was that Satan or Longhorns? Okay, fantastic. It's the proper month for it. So the first thing I'm going to do is create an environment that we'll be working in. I'm going to put Python 3 in there. I'm going to call it Evil. I'm going to have Jupyter because we're going to be using Jupyter notebooks, pandas, bokeh, and the connector for the Postgres database that we'll be pulling some data out of. Bigger? Make it bigger? Oh, yeah. Yep. Say what? Hotter? Disco. Thank you. And I didn't make it any bigger, did I? The size is okay? Perfect. But Jeremy, that's crazy. Pandas requires NumPy, which is going to take forever to build. So that is one of the things that Conda does. It's going to grab binaries instead of building from source, and it's going to figure out all your dependencies, of which it looks like we have quite a few. And so we'll get going there, and that'll take a moment, an uncomfortable amount of time to be standing up here, but not nearly long enough to go away for a lunch break or a weekend or anything else. What? The environment it's already ready already. Perfect. To activate the environment, we're just going to say source activate evil. And we're up and rolling. So I have pandas in there, Jupyter notebooks, the rest. If you're unfamiliar with environments, it's kind of like, let's say, a diaper for your computer. So when what you're working on craps, it doesn't wreck the whole place. All right, from here, we are going to talk about the sins that we might cover today. If you've completely unfamiliar with the Bible, there's 7 of them. Might not be from the Bible, might be from some other religious text. Not important. We'll cover greed, pride, envy, sloth, wrath, gluttony, and lust. If you're unfamiliar with Jupyter, it's what IPython notebooks became. If you're unfamiliar with IPython notebooks, it's the most amazing math book on your computer that solves itself as you watch. And it can talk to the internet. We will open up greed here. And if you're unfamiliar with greed, that's wanting more than what you have. So that'll be money in this case. And you're like, how do you get money? You ask people who have money for money. And where do you find those people who have the money? Perfect. There's a magazine called Fortune that prints the companies with the most money in the US every year. So let's track those companies down. I'm going to pull in pandas because we're going to be looking at tabular data. We're going to list the directory to see if we have any files that might be useful. And there's one called fortune500.xls, an Excel file. Oh no, how is it going to get into Python? Pandas has that taken care of. It's just, we imported pandas as PD, so just pd.readExcel and the Excel file that we're looking to read. And then you can determine which sheet, but this Excel file only has one sheet in it. And so we will ingest that. And it explodes. What? No, there's no module named Excel read because that's what it's going to be using to read the Excel. Probably back to the magic of Conda again. I took Melly's talk yesterday to heart, and so there will be all kinds of disaster in here to make me seem just a little bit more human and make you realize that you could do this too with the proper set of tools. XLRD. Okay. How about conda stall XLRD? If you put a bang, the exclamation point in front of whatever's going into the Jupyter notebook, it'll execute it in the shell instead of inside your notebook. I'm going to say yes so that it doesn't ask me if I really want to do it, because I know I really want to do it. Perfect. Packages linked, complete. Okay, now read the Excel. Boom. Excel is in. We're going to look at the top of here. This would be more fun if you don't know what's coming next. So these are the 10 richest companies in America. Now there's the head. In pandas, you can also call it tail. Those are going to be the 490th through the 500th losers, which is not so bad since they're still making, I think, $2 billion in annual once you hit the bottom of the list. Okay, we're going to take and mix the Fortune 500 list with, what else do we have up here? Something called email dump. Email dump is 2.2 gigabytes. I bet there's a bunch of emails in there. Let's have a look. Yeah, there's totally emails in there. Luckily, I've run this one before, but one of the things that drives you nuts is waiting for something that you don't know how long it's going to take. Since I've run through this one previously, this is going to take about 21 seconds to ingest some amount of emails. I would recommend taking a smaller sample if you're doing it for the first time, and then you can extrapolate how long the full data set will take to bring in. Percent time, when you throw that into the notebook or the command line, it will tell you how long that took to run. So when you're playing that back later, you can figure out what it's going to take if you have more. So that took us 34 seconds. Fair enough. I'm going to set my display to 6 rows, and so instead of saying head or tail, it'll show you the top and the bottom of that email list. Email data, great. We have not a number, which is not a real email address. There's Darren, there's US Nike, perfect. Down here, you can see that was almost 37 million emails that were pulled in 34 seconds. We're able to slice, and so we can look at emails number 2 million to 2,000,005. Yep, there's definitely emails in there. This is probably going to take another 20 seconds. What I'm doing here is email data is our data frame, and I'm pulling out every record that does not have a @ symbol in it, and that's what I'm using to say that's a valid email. In this particular set of emails, there were a handful of times when form validation was not working, and so people would put in email addresses that don't have a @ in them, and we're not going to be able to do anything with that. If we look back at our data frame, it looks like, yep, that's worked. We've gotten out the not a number, which is not going to be a person we're going to be able to email. What I'm doing here now is taking and splitting 36 million of those emails, bringing the name off of the domain. Because if you saw earlier back up here, I had listed the domain of every company, and that's where they receive their email. Now what I'm going to do is combine those two. And in pandas, that's just called a merge. I'm going to merge them on the domain field and enter, because I want to throw away any of those 36 million emails that don't match a Fortune 500 company. Dancing, yay, 7 seconds. We're going to throw away all the doubles, and that leaves us with almost 42,000 people represented in the Fortune 500 from companies like Calumet and Caterpillar and Consol Energy. Fantastic. We're going to create a data frame called companies, sorting these by corporation so we can tell which spot we might want to go to first. Where do we have the most users? I did not. So these emails are not my emails, but they're somebody's emails. Evil. All right. So earlier in the notebook, I had set the view to only 6 things when you ask for a data frame. Now I'm going to look for, let's say, 100. Excellent. So, well, that might not be true. So Facebook, people can have an @Facebook email without working at Facebook. People can have an @Google email or a Verizon email or Microsoft email. But as you start getting in there, if you work at General Electric, you probably work at General Electric. If you have a 3M email, their email domain is mmm.com. That's very likely that there's 176 customers there. Perfect. And on down and on down. I'm going to bring in the XLS writer. There's no XLS writer, the worst. Well, if my environment needs XLS writer, conda install XLS writer. Boom. Imports without a problem. And down here, so back to Evil, right? We came in from Excel, and we're going back out to Excel because at this particular company, that's what our salespeople's favorite thing is. And so we're going to set up a new writer, use that XLS writer engine, and have pandas go name of the data frame to Excel, call the sheet leads, and save the file. $41,000 emails later. We have a spreadsheet called Leads that contains emails from the Fortune 500. And if you saw earlier, those were all associated with a state. And so now you can hand this off to your sales folks, and if they have particular territories and they like Excel, they can sort by state, company, and then all of these folks, they can get after them, import that into MailChimp or any sort of other messaging campaign. MailChimp, another one of the sponsors. If you need to bother people over email, they're a fantastic way to do it. You are seeing that, right? You can dedupe. Probably dedupe before the merge, but yes. Thanks, Melly. Let's see if I killed the open one fast enough. Yeah, there will also be a few people who put things in there that are not completely true. But as you get into... Would you say evil? All right, off to the sales folks. They can do their own evil. Perfect. Ooh, more sins. Next up, pride. Perfect. So I think Conda, Anaconda, Pandas, the set of tools myself and colleagues work on at Continuum are fantastic. I'm going to go ahead and tell everyone that will listen about them, but I'm not sure where I should go because I can't go everywhere. This is to let you know how I ended up in Portland. Over here, we have a quick piece of Python. What it's doing is going to meetup.com. Meetup.com I used as a sort of proxy for a developer census. Many people don't like meetup.com, but show of hands, how many people are on there? Everyone who's anyone. And so what I'm looking for here in this request is Python meetups. And so this ran earlier. I would probably hit a rate limit if I ran it now, but it scraped out all of the Python meetups in the world from meetup.com and slung them into this Postgres database. So I have the ID of the meetup, when the next meetup is happening, its name, the link it has. But what's really useful here is the highlighting going crazy. Is the number of members and the lat long, which means I can take and throw that onto a map and figure out exactly where that meetup is going to take place. All right, I'm going to be using requests, the connector to Postgres, using NumPy because we'll be doing a little bit of a scikit-learn, just a tiny taste of the data science, and some math. That was quick. Writing a quick SQL query to box only the United States meetups, because right now our focus is mainly domestic, and so we're not going to be grabbing any latitudes above about 50 or below Florida or outside of the continental United States, but including Canada. I called them points. So inside the database, we have 1,800 meetups. Inside the United States, we have 819 meetups. But we don't want 819 points to be clustered when we get to the clustering below. So we want all of the people who are going to these meetups. In this case, since there's 819 meetups, a meetup in, say, Skokie, Illinois, counts the same as a meetup in New York with 1,000 people. So we're going to expand those meetups and look at how many participants we have. And of those 819 meetups, they have almost 500,000 participants. We're going to chuck those participants into a NumPy array. We're going to bring in cluster from scikit-learn. No module named sklearn. Worst. We want scikit-learn. Package metadata. Oh, there's nothing called scikit-learn, but luckily, Conda knows kind of what's close to that. Did you mean scikit-learn? Yes. But that has SciPy in it. SciPy depends on Fortran. How is it done already? Conda is magic. We may soon. We have Keep Calm and Conda install. I'd show you the sticker on the back of the laptop, but I'm worried if I jiggle this cable, everything will go down again, and we'll all be late for lunch. So number of clusters I want, we're gonna say we're gonna go with 40. K-means is a clustering algorithm. I'll bring that in there. We're going to try and fit the algorithm to all of our points and see how long it takes. Maybe as much as 20 seconds, but probably a little bit less. I'll dance for you. %113%. It's working very hard. We'll look at the labels. There should be about 500,000 of those. All the 16 top latitudes, longitudes, and I'm going to then take and try and count these. They're roughly represented by regions. I'm going to take the size of the meetup and the sorry, not the size of the meetup, the size of the region, so all the meetups in a particular city or area. Another library that we work on is called Bokeh. It's for data visualization. I'm going to bring that in now. So I just pulled in the outlines of all the states in the United States, because that's where we're trying to find our meetups. We're going to sketch those onto the background. We're going to call our visualization Python meetups. I'll put a toolbar on it, make it about the size of our window here. We're going to decide we only want the 16 most popular meetups, the 16 most popular regions. Output notebook is how you get Bokeh into the notebook. You can also output HTML files for emailing someone, for putting up on your web server somewhere. And show is how you look at it. And here we have the 16 most popular Python regions, everywhere from Denver to Toronto, Chicago, Portland! And so now I'm looking at the labels that scikit-learn kicked out, the k-means, and how many people are there. But this really does me no good, as I don't know which city number 2 is. Number 2 is probably New York, but it could be San Francisco. And so we will go down here and throw all of our latitudes and longitudes that are connected to these into Google, which has a nice free reverse geocoder. If you're not familiar with reverse geocoders, it's when you take a latitude and say, what city does this fall inside of? What state does this fall inside of? We're going to use requests to do that. Give me the most frequent 16. Perfect. So we have 100,000 folks in New York, about 80,000 in San Francisco, down the road in Mountain View, about 60,000, and so on till you come down to Portland, the 13th most populous Python region. So that's where we'll be going. We'll be going to Portland, also LA and San Francisco and Mountain View, but Portland. For Python Pride, for Anaconda Pride, to tell people the story. More sins. Where are we at? Envy, perfect. This one, we're brushing up. Yes, Rachel, 5. Oh no, not a question. That many minutes. Fantastic. Envy, that's anytime you want something that someone else has. In this case, it's your employees. And I should probably run some Twitter ads to lure them to continue them. But whose followers do I target the ads to? Because if I just target them to everyone, it's going to be very expensive. And so here we're going to use an already executed notebook. I bring in Twitter, I look at my timeline statuses to kind of get an idea for what I'm up to, look at my CTO's friends. It gives me the list of all of his friends. We take and pile those friends together with the Twitter list of all employees at the company. From there, we run a counter and figure out how often the most popular accounts are occurring inside this large pile. And then take out the employees who follow each other. And so the most followed account by 30 employees would be this one with 22, 21, but these 7-digit strings mean absolutely nothing to me. And so you go back into the Twitter API and say, for that string, kick out their name. And so it ends up being, for me, a lot of things I'm expecting. Most of the company employees, they follow the company. Most of the company employees, they follow the CTO. But there's other people who are important in the Python community. Maybe we want to target folks who follow the creator of Pandas, Wes McKinney, or one of the trainers, David Beasley. You'll see other Python rock stars there. Whoever Ocean Kid Billy is. I know. I'm also a fan. You can filter the same thing through by printing their name and wrapping it with http.twitter.com, and then you're able to click into any of those accounts, see if they're quite a fit for what you're trying to do, and then you're going to take those names and add them into a targeted audience. So people that follow those accounts are probably people who are staying up on the latest happenings in Python, and that's going to be probably the kind of people who you're wanting at your company. Fantastic, we've made it to Sloth. So I've got one of these things. Sloth is being lazy. This thing's an Apple Watch. The Apple Watch allows me to be all kinds of lazy, and Python allows me to be even lazier. I have a Nest thermostat in my home, but sometimes I'm in bed, and I want it to be cooler, because it's Texas. But I don't want to get out of bed. And so there's an app for the phone and the watch called Workflow, which is great because it can do HTTP requests, but the problem is that Nest only takes commands to change the temperature as HTTP puts. So Sloth.py is just a quick slice of Python that takes and allows the watch to phrase it Jeopardy style. It needs to ask in the form of a question. And so instead of saying, what's the temperature, and getting the temperature back, it says, could you change the temperature to whatever I asked for the temperature to be? Instead of, please change the temperature. And since it's asking in the form of a question, the Flask server is able to take that in and then go over and ask the question in the proper way to the Nest API. Push the button on the watch, goes upstairs to the Mac Pro, negotiates with Nest, AC kicks on, I'm still in my bed, lazy as all hell. All right, we have, how many more sins left? Ooh, wrath, gluttony, and lust. Oh. All right, so lunchtime is up. I'm probably getting in the way of gluttony. Wrath, you'll be angry if I get in the way of that lunchtime. And as far as lust, you had a question about whose emails those were? That was the Ashley Madison dump.
People use their work emails?
I'm afraid so. Very engaged in your chat.
There's a potential national security risk because of the Ashley Madison database because of the number of government employees who use their.
And so I was saying, even in the form of marketing, in that money is the root of all evil, or the love or the intent to acquire money is the root of all evil. But yes, there's plenty of other very bad things. We'll try to stay. And everything that you can use for bad, you can turn around and use for good. So don't be evil. Thank you very much. And if you have any questions, now is good. If you'd like private questions, that too. Or if you'd like a shirt that says Anaconda on it, I've got a bag full of those. So. Questions?
We actually don't have a crush on
Yes, sir.
Are these available on GitHub somewhere?
They will be soon. Yes. Bokeh here for the plain purpose of I'd never used it for mapping and had wanted to try and see how long it would take, and that was effectively one of the gallery examples with a series of points dropped onto it. I think Bokeh probably for some of the flexibility. So I showed it being used in a notebook, but you can also take and output it to straight HTML. You can take and run it as a streaming server. And that's I used it for something very simple, but that's just the very tip of the iceberg as to what you're able to do with the full bit. Allows you to write JavaScript visualizations without writing any JavaScript from Python mostly, but also R and Julia and Scala. Enjoy your lunch.